here this question is asking, given the following two pattern pairs x1 to y1 and x2 to y2, which are to be stored in a BAM. x1 is equal to 1 1 1 1 and y1 is equal to 1 1 minus 1 minus 1 and x2 is equal to 1 minus 1 1 minus 1 and y2 is equal to 1 minus 1 minus 1 1, and the noisy vector to be recalled is xt is equal to 1 minus 1 1 1 1. So A part is asking the calculation steps of the weight matrix W, and B part is asking the calculation step of the steady state recall pattern pair of the noisy input vector xt. The sum rounded to 2 decimal places of each of the diagonal elements to the power 2 of your calculated weight matrix W. Okay, so here what they're asking is, in the A part we had to calculate the weight matrix W, and in the B part we had to calculate, we had to actually use the noisy vector to bring back this x1 and y1, something like that. Okay, but just follow the steps, like you will see this clearly. First let's do the A part. A part is asking us to calculate the weight matrix. So let's look at the x1. Let's list the values. X1 we have is, let me use a different color. So here x1 given to us is 1 1 1 1 and y1 given to us is 1 1 minus 1 minus 1, and then x2 given to us is 1 minus 1 1 minus 1, and then y2 given to us is 1 minus 1 minus 1 1. Okay, these are the things given. Now in order to calculate the weight, the equation is, the generic equation for the weight is summation of k is equal to 1 to k x of k transform yk. Okay, as you can see, we have to sum how many number of x and y we have, and what we have to do is we have to transform the x and multiply that one with y and sum with how many of them we have. So here if you look at this, we have x1 y1 x2 y2, so totally we have 2 xy's. So we can say k is 2 in this case, and then what we have to do is we have to do the transform of the x. So which means currently x is in a row, we have to change this one into a column like this. So we are going to have the 1 1 1 1 like this, and the transform of the x is multiplied by y. So y stays as it is. Y is 1 1 minus 1 minus 1, and then we have to keep on adding them together. Like if we have x1 y1 x2 y2, we have to just keep on adding. Like since we only have 2, we have to just add one more time, like x2 and y2 we have to add them. So x2 we have to do the transform, whatever the x value we transform that. So it means this is going to be vertical and top to bottom. So top start from the first one and the bottom goes to the last one. So 1 minus 1 1 minus 1, and this is the x transform, x2 transform, and then the y2 remains the same, which is 1 minus 1 minus 1 1. Okay, now we have to do the matrix multiplication. Now I'm going to go ahead and do it in the new page, which since I don't have enough space here. Okay, let me copy from here. Okay, so let's bring the matrix multiplication here. And we know whenever we have matrix, we look at the rows first and then the column. So here if you look at this is a 4 rows 1 column. So this is a 4 by 1 matrix here, and this one is a 1 row 4 columns, so which means this is a 1 by 4 matrix. So since you have to see if these two are matching, then only we can multiply. So 1 by 1, usually when they give, it's gonna match, but just to make sure 1 by 1 it is matching, so it will multiply, and the output of this one, when you multiply these two, you should be getting 4 by 4 matrix. Okay, same here. This is a 4 by 1 matrix right here, and this is a 1 by 4 matrix. If these two are matching, we can multiply, and the output will be this one, 4 by 4 matrix. Okay, and when you multiply matrix, how does it goes is you multiply the column by the rows. So so if you look at this, this is 1 times 1 1, 1 times 1 1 again, minus 1 minus, so you have to just multiply each number and replace them. So since all of them are 1, and if you multiply them, you're going to get the exact same thing 4 times here. So the one after you multiply here is going to be like this. You're going to have a 4 by 4 matrix, but all of them are going to be 1 times this, which is 1 1 minus 1 minus 1, and you're going to get it 4 times. Okay, this is the first 4 by 4 matrix we are going to have after multiply this. And the second one is again 1 times this. So when you multiply 1 times this, it's going to remain the same. So 1 minus 1 minus 1 1, and then when you multiply by minus 1, that's going to be opposite sign. So this is going to be negative 1 here, then this is going to be positive 1, and then this is going to be a positive 1 again, and then this is negative 1. And the other two are like top two, so you have to just copy them. 1 minus 1 minus 1 1, and then minus 1 1 1 minus 1. Okay, once you have got the matrix multiplication, then you have to add them. You have to look at the corresponding values. Like if you look at first row first column, you have to add with the first row first column. So 1 plus 1, you get a 2, and then second column, I mean first row second column, 1 minus 1, which is 0, and then third column, first row third column, this is minus 1 minus 1 minus 2. Like that, you have to add corresponding rows and columns value. So you will get this 2 0 minus 2 0, and then 0 2 0 minus 2, and then 2 0 minus 2 0, and then the last one is 0 2 0 minus 2. And as you can so this is a 4 by 4 matrix. We are just adding with a 4 by 4 matrix. Now we end up having this, and this is our W. Okay, this is our final W. But if you want to calculate the value of the W, what you have to do is okay, what you have to do is we have to take the diagonal of this and square them. So I say sigma omega square, which is equal to the diagonal. If you look at the diagonal of this one, that is this 2 2 minus 2 minus 2. So this is going to be sorry, 2 square plus 2 square plus minus 2 square plus minus 2 square. So here we are going to get 4 plus 4 8, 8 plus 8, which is 16. And in the question, if you look at this, they are asking us to give it in 2 decimal places, which means I had to put 16.00. Okay, that's it. And this is our weight. And let's look at the B part. So this is the answer for the A part. So what you have to do is you have to follow this. I go through this again. So what you have to do is you have these are the matrices given, and this is the equation you have to use to calculate the weight. And depending on how many x and y you have, like if you have 2x and 2y, the k is 2. Here we have 2x and 2y, so that's why we have k is 2. And then what you have to do is you have to take the transform of the x and then multiply that one with y. So when you do the transform, the horizontal become vertical. Okay, that's why we got this one right here. And then multiply and add each x and y. So we only have two x and y. We add them together. We multiply and add them. And when you do the multiply, you get this and you add them, and then you look at the diagonal and then square them and add them, and that's going to give you final weight. Okay, and that's the A part of this. And let's look at the B part of this one. And the B part of this question is asking the calculation steps of the steady state recall pattern pair of the noisy input vector xt. Okay, the calculation steps of the steady state recall pattern pair of the noisy vector xt, the sum rounded to 2. Okay, so we have to just recall using this noisy vector. We have to recall this x1 and y1 and check them. Okay, so in order to do this one, what we have to do is we have to use this equation. And first let's look at the noisy vector given to us. The noisy vector given to us is 1 minus 1 1 1. That is our xt. 1 minus 1 1 1. Okay, this is a matrix given for the xt noisy vector. Now what we have to do is we have to find the y of t. So in order to do that, we have to use the equation gh xt times the weight. And weight matrix, we already have it right here. Weight matrix is the one we derive right here. Okay, I copy paste this one. Or I can rewrite. You have to just remember, like 2 0 minus 2 0. Yes. Okay, so I put the first. Let's put this like this, gh. Okay, and the bracket. And in this one, we are going to have the xt, which is 1 minus 1 1 1, and this one multiply by the weight matrix, which is 2 0 minus 2 0, 2 0 minus 2 0, and then 0 2 0 minus 2, 0 2 0 2 0 minus 2, and then 2 0 minus 2 0, 2 0 minus 2 0, and then 0 2 0 minus 2, 0 2 0 2 0 minus 2. Okay, so this is what we have here. Now what we do is we have to multiply this one, but before multiplication you can look at this. This is we look at the rows first and then column second. So here 1 by 4 matrix. This is a 1 by 4 matrix, and this is a 4 by 4 matrix. And since these two are matching, we know this can be multiplied, and the output will be this one, 1 by 4 matrix, which means we are going to have one row for 4 columns. Okay, so here what we have to do is we have to take each column and each row. The row should be multiplied by each column. So 1 times 2 2 like this. 1 times 2 is 2, minus 1 times 0 is 0, and then 1 times 2 is 2, and then 1 times 0 is 0. So you get a 4 for the first one. So the answer we are going to have is 4 right here, first one. And then second one, second column multiplied by the row. So 1 times 0 is 0, and then minus 1 times 2 is minus 2, and then 1 times 0 is 0, and then 1 times 2 is 2. So 2 plus minus 2, that becomes 0. So like that you have to do for all of them, like this row multiply by each column. So when you multiply, do that for next column, you get minus 4. When you do that for the last column, you get a 0. Okay, and this one is, you have to put a gh in front. Okay, now this GH is what does it do is, like, if you have a positive number or 0, that turns into 1, and if you have a negative number, that turns into -1. So here we have a positive, this is a positive number, so that's going to be 1, 0 also 1, and if you have a negative number, that replaces with -1, and then if you have a 0, that's also 1. Okay, 0 or positive number is 1. If you have a negative number, that's -1. So this is what we get, and this is called YT. Now what we have to do is, we have to multiply this YT, let's say capital YT. We have to multiply this YT with the transform of this weight matrix, and see if we are getting x1 or anything like that. Okay, we have to see if we are getting x1. So what I do, to do that, I go to the next page. I go and create a next page, and I write the equation. Now what we are going to do is, we are going to take GH and then YT multiply by W transform. Now YT is the one we just derived right here. That is 1 1 minus 1 1 1 1 minus 1 1, and the transform of the weight matrix is this one, like this one flipped. Like, if you look at this weight matrix, you have to think like you are flipping diagonally. Like, this is the middle part, and you flip this one. So these 2 minus 2 comes to the bottom, these 2 plus 2 go to the top. So the new matrix is going to be, the -2's will be replaced with 2, and these 2's will be replaced with -2. Okay, so I keep the diagonals remains the same. 2 2 minus 2 minus 2, 2 2 minus 2 minus 2, and only these two, -2 is going to be +2 now. So let me put each values. 0 2 0, 0 2 0, and the next value is 0 0 2, 0 0 2, and here we will have a -2 here. So -2 0 -2 0, -2 0 -2 0, and then the last one is 0 -2 0 -2, 0 -2, wait a minute, 0 -2 0 -2. Okay, this one is belongs to the last column. Okay, now this is W transform. We just flip it diagonally, and whatever is on top comes to the bottom, whatever bottom comes to the top. So initially we had this -2 on top and +2 on the bottom. Once we flip it, this is gonna be like this. Now again, you do the same. You do the same thing. You multiply this row by each column. So first of all, if we take this 1 multiply by 2, that's going to be 2, and then 1 multiply by 0 0, and then -1 multiply by -2, which is +2, and then 1 times 0 0 again, so which is going to 2 plus 2, which is going to give us 4 here. And this is a 1 by 4 matrix, this is a 4 by 4 matrix. So the 1 by 4, this is a 4 by 4, these two are matching, so we can multiply, and this is going to be the output 1 by 4. So we are going to have 4, and then when you multiply this row by the next column, you're going to end up getting 0, and next column 4, and next column 0. Okay, so once you get that, again same approach, like this is GH of it, and whatever the positive or 0 will turn into 1. If you have a negative value, that turn into -1, but here we don't have any negative value, which means all of them are going to be 1. And now if you compare this one with the matrix given to us, that is actually x1. X1 is 1 1 1 1, so we brought the x1 here. Now what we have to do is, we have to see we can bring the y1 using this. So in order to try that, what we do is we take the GH of this x1, multiply by the weight matrix again. X1 is this, the original weight matrix is this one right here. We multiply both of them. So let's do this in the next page. So GH of x1w. Okay, x1 is just once. So I put GH 1 1 1 1 and the weight matrix we have is 2 0 minus 2 0, 2 0 minus 2 0, and then 0 2 0 minus 2, 0 2 0 minus 2, and then 2 0 minus 2 0, 2 0 minus 2 0, and then 0 minus 2 0 minus 2. Wait, this one, that is this one, not this one. This one is transform. So I'm looking at this one. This is a W. So 2 0 minus 2 0, 0 2 0 minus 2, 2 0 minus 2 0, and then 0 2 minus 2. 0 2 0 minus 2. Okay. So now what we have to do is we have to multiply this row by each column and add them. So first, if you look at the first one, 1 by 2, 2 0 0, so 1 by 2, 2 plus 2, so that's going to be 4. Like that, you have to multiply each column, this row by each column, and this is just a 1. Okay. So we will, if you do that, you will end up having 4. This is GH of 4 minus 4 minus 4, and a positive or 0 will turn into 1, negative values turn into minus 1. So we will end up having 1 1. This is negative, so minus 1 minus 1. And now we have to see if we are getting anything here. And if you compare this one, this is our y1. So we recall the y1 using the x1. Okay. Now you can go ahead and try one more time. If you can get the x1 back, take the GH of y1 and multiply by W transform. So the y1 we have right here is the y1 we derive right here. This is the y1, but yeah, we put that one right here. That is 1 1 minus 1 minus 1, and then W transform. This is W transform is we flip it diagonally, which means the 2's are going to be negative 2 and negative 2's are going to be 2, and the diagonal remains the same. So which is 2 2 minus 2 minus 2, which remains the same, and then this is 0, and then this is 0 here, 2 here, and then 0 here, and this is going to be 0 here, 0 here, 2 here, and here we're going to have negative 2 0 0 here, and then here we're going to have 0 negative 2 0 here. Okay, now what we have to do is we have to multiply this row by each column. So first we multiply 1 times 2 2, 1 times 0 0, so 1 times 2 2, 1 times 0 0, and then minus 1 times minus 2 plus 2, and then minus 1 times 0, that is 0. So first value is 4. Like that, you have to multiply this row by each column. So you're gonna get 4 4 4 4, and in GH, if we have a positive or 0, that turns into 1. If you have negative values, that turns into minus 1. Here we have all of them positive, so which means we are going to get 1 1 1 1. And if you look at this, that is our x1. Okay, so we brought our x1 back. Which means we can finally conclude. Hence, in this problem, statement using problem statement using the noisy vector xt x1 is recalled, first followed by y1. Okay, and that's our final answer. And that's it. That's how we do this kind of problems. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.